Good afternoon, all of you. Myself, Mateen Ahmed. I hope my screen is visible to all of you. So, what we have seen in our previous section with Dr. Abhidev and Dr. Chaparwal, what they have mentioned, what they have shown you is the macro scale and the microstructure aspect of AM PravaH. What are these modules? How you can perform the simulation using these modules on AM PravaH. So from this, we have an idea. There's these simulation, these AM-PravaH simulation, or any sort of simulation does take a good amount of time depending upon the accuracy. Of course, it will be less than the experimental time goes in experimental cycle, but still, as it totally depends on the computation, it is time consuming, and we want to accelerate this flow better. So we have integrated these two modules that I'm going to discuss in today's session. That is the Q and the
Hello,
array
sir.
module of Emprava. Yes, yes,
Can you hide that pop-up screen on the slideshow? Yeah, thank you.
right. Okay. Okay. I think we can proceed. Your process. Proceed further. So as we all know that when it comes to additive manufacturing, especially the metal system, running just one simulation is never enough. Whether we are trying to optimize process parameter or we want to develop any new material, we usually need to run dozen of simulation, if not hundreds. So to explore how the system behaves under different condition, we need to run multiple simulation depending upon what our requirements are, what are the desired quality which we want in our system. So based on that, we need to run multiple simulations. But here's a challenge that doing this manually is not only time consuming, but it also has a bad basically use of, it is also a bad use of computational resource that you have. So you run one simulation, then you sit and wait one to end to start with the another. So to tackle this problem, we have uh, tackle all this problem, which is, single simulation is time consuming, but when we are waiting one and to run to move to the next, it entire is a very long, it entire makes it a very long process. So exploring parameter space, again, it will become a very challenging, and babysitting each simulation until it ends, it's exhausting also, and also very inefficient when it comes to time management. So here comes the Q module in AM PravaH, which is, from its name, it's a very simple analogy that is being represented over here also, that you stack all your simulation one after the other, and you just give it to the system, and it'll start, uh, once you start executing it, it just, at the end of the day, basically, you don't have to sit and wait for one to complete to start another. At the end of the day, you will have the complete data set of, suppose you have 100 simulation, you want to, there's some new material and you want to explore it for various process parameter. You just give it in a queue, and once it is done, you'll have the entire database. So in the meantime, when you were waiting for the simulation, you can just do your analysis part. You can just do your other research work, and at the end of the day, you'll have your data set. So what we are doing is, with this module, you are definitely the throughput will be improved, and the process, the parameter exploration that being done, that will become easy. And wherever if there is any failure in the system, it'll log that, it'll showcase inside AIMPRAVA itself that if there is any error basically. So it is a very good use of resources that you have, very optimized in a very optimized ways. So here I've taken a process parameter optimization case for this new alloy that Dr. Abhirdeep mentioned in his last in the very last session. So as comparatively, it's a new alloy in this additive manufacturing space. So if we want to explore this, so if you are also planning to explore this in your system, so you can use case this this Q module in PravaH and to get best out of it basically. So to start with, I have prepared this very small case. We'll see how like these are the few cases that we want to see how we can arrange a queue in PravaH for all these parameter space. So I'll open the PravaH. You guys are already familiar with the GUI, I guess. We'll wait it to open. Yes, so we have this window over here. So directly go onto the Q module. It's the fourth button in the top navigation bar. So you can give the name. So we are running it for CMSX4 and say we are doing we're exploring the process parameter optimization part. So very first part is to create a directory where you want to store this project, as you were doing this previously also. So we'll create a directory and we'll save it in the same where we have our entire course. So, so we have created the project and now you can clearly see at the bottom that we are in a queue mode and the project is being continued. Now the next part is we'll directly go to our macro scale module. So this Q module is currently for the macro scale LPBF and the microstructure module. So basically you can run Q in these two modules. So in macro scale, you go to the material part and here you select the material. So we have the CMX4 material. This is the alloy that we are selecting here. If you want to change anything here, you can directly just change it and do back. These are the process parameters. So these are the default values that I'm taking and the accuracy if you want to change. So I can change accuracy say to 20 and maybe I can increase the number of code to 8 and I go back. So once we have a base case ready, we'll just simply add it to our project. So for your understanding, I would recommend that it's only best if we have some sort of naming convention ready prior. So as you can see in our assignment, uh, I have already mentioned that laser power we need is 180 and beam diameter is 60. So we need to edit it in our process parameter window. So just change it to 180 and this to 60. Go back. Now do add to queue. CMX4. Let me check the name. It's _01. So I give it a name. Okay. Now we need to change the beam diameter. We go to the process parameter again. We just change the beam diameter to 70, then 80. So it's simple. You just do it 70. Go back, add to queue. CMX4 underscore 02. Okay. Again, go to changes to 80, back, add to queue, 03. So like this, you can create queue, and you can go to this queue menu, and you can check here all the queue that you have created with these queue IDs. Further, if you want to edit this particular queue, suppose I want, if I want to edit the input that I've just given, I can just select it. I can go to edit input, and this is what I will see. So I can, if I want to change the power, say, so I'll, this is the material properties, molecular weight, all the thermophysical properties that we've already input in the material section of macro scale. Now these are the properties for inert gas. These are the process parameters. So remember, we have given it to 180. Suppose we want to change it to 100, say. So we can just edit it from here. We can do the save input, and it is saved. So this is how basically you can create a particular queue. And if you want to add some sort of rules, so there's one more shortcut that we have integrated. Suppose I've taken this as a base case, CMSX4 underscore 03. We can see the inputs by tapping on edit input, and we can see that the power that we have given here is 180, correct? And we want to make similar cases. What can we do? So we can just create rules. So first of all, we need to save this input. We can tap on create rules. Now what does this mean? This means that we want to create a shortcut, 3 more simulation projects, simulation 1, simulation 2, with these name, and we just want to change the power in these. So we want everything to be saved. Material properties or other process parameter will remain same, and we can change the power from here. So if we do this, we'll have this in picture. Basically, if we select this and we say edit input, so we can see here that the power is 200, and for simulation 2, if we do the edit inputs, the power is 210. So this is how basically we can create a queue. So the process which is being followed to create a particular queue, that need to be uh, done very with very all the, basically with very sincerity. There need to be 0% error, basically, because you're going to execute this, and one by one each simulation will get executed in series. So I guess I'm a bit clear about this process. Now how can you run this particular queue? So there is a button called run LPPF queue. So once you tap on this, the simulation will start, and one by one you will see here. I can see that this particular case start running, and we can go to our macro scale queue mode, and here we can see that the powder bed is being start for this particular module. So remaining thing will be same. There is no difference. If you want to check the process, if you want to check how much powder spreading has been done, and you want to see the post processing, you want to do the post processing, you can do it from here while the project is being executed, or you can go to the project menu directly. You can do it from there as well. So I'm hoping that you guys are following me while I was explaining to you hands on, but you guys must be doing it on your system also. Tell, so this is the way basically how you can execute your queue. So this case was specially for run LPBF. So if you're doing a microstructure, if you are changing parameter of a microstructure, and you have to run this particular button, and if you want to terminate, suppose if you want to delete some particular case, you can just select and delete this case, but you have to done it before you do the entire execution. Okay. Now, how can one terminate this particular queue which is running? You can just tap on terminate, and this project is being terminated. Of course, we are not going to wait this to be completed, as this might take quite good amount of time, right? Now, as you can see that in this queue mode, there are only these three buttons which are working. So yeah, WLAM and the AI module is not working. If we want them to work, we need to exit this particular mode, and we can do it by tapping on this button simply, exit queue mode, and we can see that we are back. Now we can use the other two module as well. So what we are getting for queue module is, so it just makes it easy for you to just collect more and more simulation data, right? You can just run couple of, I don't know, 50 or 100 of simulation you can run if you're doing parameter if you're exploring process parameters. You just add on all the possible different combination set of process parameter, and you have that entire data set. I hope I'm clear up till now. Now we have enough amount of, now we know how we can generate a good amount of data. We have of course we're going to perform experiments. Of course we can perform now many more simulation, but what if we can integrate AI to it to get some more insights? So there comes our AI module in PravaH. Definitely using simulation, we are saving a lot of time, we are saving a lot of resources, right, and money as well. So when we are performing experiments along with simulations, we are saving all of it. But with time, we know that we are having a lot of data also from, be it simulations or experiments. So there comes our AI modules in picture, where what we can do is we can train all the data that we have. We can train it on whatever the desired feature we want from a particular system, and use that particular data in future. So we have the data, we don't want it to go to waste, we just want it to give us more and more interesting results. So the process for AI module in PravaH, it's very simple. This again, this module makes the entire process very powerful. What we need to do is, we suppose for a different set of process parameters, we have, as you can, as you've just seen that we are changing the power, and we are changing the diameter, laser diameter, for the particular case that we just run some queue simulations. So similar to that, in more cases, we might have more than two parameters, and at the end of it, we are getting some output from it. It could be porosity. Maybe porosity is something that we are looking for. Maybe we want high porosity, maybe we want less of it, and maybe we are just checking the shape of We just want to optimize the shape of our melt pool. So at that time, this AI module comes into picture. We just train our AI module on the targeted output and the input data. Once the model is trained, we can just simply use this model to do the thoughtful prediction, and we can come out with the better understanding. Better we can do the better decision making of how narrow further we can do the process parameter window that we already have. So to get you started with a this particular module, what I have taken is this particular case study. I'll show you directly the paper. So in this folder itself, this is the particular paper. This parameter optimization for Ti-47 alloy. So they have performed some experiments, and from these experiments, what they are changing is these two process parameters. This is the power and the speed, and they are getting different output. So with these are the things that they are calculating once the experiment is done. So these are these are total 36 experiment that they have performed. Of course, this number is not great when we are running an AI-based simulations. We need to have more and more data. So one idea could be that you have this sort of data set. Now you can perform simulations. You can perform 100 of simulations with the different process parameters. By changing these two process parameters, and you have more and more data. Right at that time, it'll make more sense for us. So this is the data that I have copied. You can see. Now for this particular session, I am taking these as the input parameter that we are changing, and width I'm taking as an output parameter. That is, as you can see over here. So very first part again is to organize our data set. Before we give it to our AM PravaH software, we need to organize our data set. How we can do that? We just need to make several different CSV files. One is for features, the other one is for labels. So as these are the features, input features, this will these will go to our train underscore feature.csv, and as these are the output parameter, so these will put in the label. So for corresponding, the number of these should be same, otherwise it won't work. And all the input that we are giving, that should be in the numerical format only. So this is how basically we can arrange our data set. So train underscore feature, you can see it from here. Mm, and give me a second. Like this, you can see this is the width, this is the feature part. Let me try to open this once more. The permission, I guess the permission is not given. I'm not sure why. Yes, we can see here. These are the train underscore feature.csv. So this is how you can basically arrange your data set in two different files. And there is this another file that we will use for prediction purpose. So I think first we should go with the training part. I'll demonstrate the product to you, how you can use it. Okay, we have all software is already there. I think we'll create one different case. We'll give it a name. It is recommended to give name which makes sense so that in future if you want to refer you can do that. Just click OK and we'll directly go into this. So the very first part is you give a unique name. Again, we are doing it's for type 47 process parameter optimization. You can give a unique name to your model. So it's not, maybe you need to create more than one particular model. So you can just give it a name. Then provide the model complexity. This depends upon your data set. This complexity number you can increase to, again, it could be 100 plus also. So you have to change this particular number and see how the training has went. If it's going good, then you keep this one only. 64 is recommended from my end. You guys can try with the different values. If you are getting better result, you can switch to that also, and it will change with the different data set. So now we need to import the data. The first is we need to import the uh, training.csv in this input data, and the target data will input the feature.csv that we have created. So for me, the project directory is different. I have saved this case here to train feature.csv. I'll import from here, then train label.csv. These are the two files that I've just shown it to you. So once this is done, you just tap on train and it'll start the training. So the name, this training agent name, you can give any name to it. It's just, it should sound unique to your particular project, right? So this is how basically you can initiate the training. And now if you want to see how the training is happening, we can just tap on launch console maybe, and it will take us to this particular window. So we'll go to scalar, and here we can see this entire training process, basically how the training, these are the validation set, there's a training. You can just see the learning part also, and if we can just refresh it to see if the model is learning anything or not. If you want to see the backend, if you guys understand this machine learning TensorBoard, you can just see this part. It gives you the idea of what the network actually looks like. We are using a deep learning based model. So we can see at this particular point, since training is going good, we can also look into the embed terminal that we have provided inside GUI itself. Once the training is done, it will give us the R2 score, which will showcase us how better our model is performed on the test set, basically. You can see here this part. So the good part is that this won't take more than 5 minutes. And once the model is prepared, when the model is ready, you can just use it and do the prediction is matter of seconds only. I'll showcase that to you. Let's see if it's done or not. Yeah, it's still going on. Few more seconds, I guess. Yes, can refresh from this particular button. These are just weights and graphs. Model is still learning. So yeah, it's done, I guess. We can see the auto score coming as 0.95, which is quite good. And if we want to do further prediction, we can. I think now I can tell you what this particular predict underscore feature.csv is meant for. So now the model is ready, and in this particular file, we have these two process parameter. Now for these two process parameter, if we want to find the what would be the width, so what we can do is now we'll just go inside our project. Inside this, there is a AI folder, AI directory. Go to saved model, and this is the model that we have been working on, which we have just developed. Now go OK, and the project is loaded. Now we'll input the predict underscore feature, and we'll do the predicts. These are the two width that our model just predicted based on the input which we have just provided. So this is how basically you can use your AI model. I have just showcased you how you can from scratch, how you can develop, how you can start with the organizing the data set which has to be used inside AI model. Once you have organized the data, again you can change this particular value and you can try training different model and see how the model is working. You can try different combination and you can check for which you're getting the best result and you can use that particular case. So this is how basically it is being done. So yes, I think this is from my end. I hope you guys have done it simultaneously. Thank you all of you.